Namaste and welcome back to our regular distance learning education. It's me, your science teacher. Today I am going to teach you the chapter acid, base and salt from class 8. In this chapter, we are going to discuss more about the characteristics of acid, base and salt. Similarly, indicators to indicate or distinguish the acid, base and salt. And in slide, we are discussing what we discussing is given in the slide. In slide, you can see that the acid, base and salt. That is acid, we separately discuss about the acid, base and salt. This slide please. Those substances, just remind this thing, those substances which are sour in taste, may or can be described as acid. That is, we eat different types of food substances in our daily life, or we use different types of substances in our daily life. Knowingly and unknowingly, we are using either acid, base or salt. And I hope after this class, you all will be find or you will be easier to find the acid, base and salt. What are the characteristics of acid, what are the characteristics of base and what are the characteristics of salt. So, in slide you can see that we eat apple, orange, lemon and different types of fruits that contain acid, but we do not know whether it was acid or base. So, similarly, some substances like limestone which are used in our daily life is base. So, we use edible salt in our food, that is example of salt. Similarly, there are the different substances which are using in our daily life, whether they are acid, base or salt. So, what is acid? Then we may easily define the word acid, that the word acid is obtained from or derived from the Latin word acidus. Remind this point, acidus, A-C-I-D-O-U-S, acidus, which means sour in taste, means those substances which on tasting have sour taste, they may be defined as acid. Similarly, those substances on RNS concept, this is the RNS concept of acid, and this concept defines the acid is a substance which gives hydrogen ion, when dissolved in water. That means, if the substances that contains acid when dissolved in water must furnish or give H plus ion, that means hydrogen ion. This is the basic characteristics of acid. For being acid, all the substances must contain hydrogen ion, which is given by the RNS concept. You can see the example like hydrochloric acid, sulphuric acid, nitric acid, carbonic acid. See the example, hydrochloric acid HCl, sulphuric acid H3SO4, nitric acid HNO3, carbonic acid H2CO3. These acids when dissolved in water gives H plus ion, that is hydrogen ion. I described the 2 points, that is, one, the substances which have sour in taste are considered as acid. Similarly, those substances which when dissolved in water must give H plus ion, they are also termed as acid. Now, you can see in the right corner of the picture, there is lemon, a piece of lemon and a yellow paper, that is the indicator that indicates the change of paper that dipped in lemon shows it is acid in color. We will discuss more about that indicator on later classes. So, just remind these things, those substances on our daily life which we used must have sour in taste to become acid. Similarly, the acids are mainly of two types. On the basis of source or from where the acids are obtained, the acids are divided or categorized into two parts. One is organic acid, another is inorganic acid. So, organic acid means those acids which are naturally occurring or obtained from plants and animals, which can be extracted from plants and animals, are called organic acids. Before Euler, he synthesized acetic acid, we may say that he synthesized acetic acid in the lab. Before that, it was said that no organic acid can be synthesized in lab. No organic acid can be synthesized in lab, but nowadays different types of organic acid can be easily synthesized in lab. So, organic acid means those acids which are naturally occurring or found in plant and animal, or source are naturally occurring substances like plants and animals are called organic acids. For example, you can see citric acid, lactic acid, tartaric acid, ascorbic acid, formic acid. You can see different types of acids like citric acid, all citrus fruit like orange, lemon, it contains citric acid. In milk you can find lactic acid. These are the different we may say that is nettle. When we touch the nettle, then we feel the burning sensation. That means due to the presence of methanoic or formic acid in the nettle. Similarly, our eyes become more difficult, or tears falls from the eyes when you cut the onion due to the acids that found in the onion. These are the acids or those substances or those acids which are naturally occurring are called organic acid. Similarly, inorganic acids means that is extract from the mineral sources or easily synthesized in the lab. You can see in this slide the acids which are prepared in the laboratory are called inorganic acid. Example, hydrochloric acid, sulphuric acid, nitric acid, etc. And in this example you can see the hydrochloric acid, just except from the other acids, hydrochloric acid is also produced inside our main body, that is in stomach. For the digestion process, hydrochloric acid is necessary, but it is not considered as the organic acid. It does not fulfill the properties for being the organic acid. Now, see, what are the properties of acids? The properties of the acids are divided into physical and the chemical properties. Some physical properties are listed below. That is, acids must have sour taste, like there are some exceptions, like some acids like steric acid, boric acid, salisylic acid do not have sour taste. These are the exceptions which do not have sour taste, but they are still acid. Similarly, acid turns blue litmus paper into red. Acid turns blue litmus paper into red. That is, in litmus paper, if you dip the wet blue litmus paper into the acid, the color must change into the red. Similarly, another indicator, methyl orange. The color must be changed into red for being acid. Similarly, for phenolphthalein, it is neutral to the phenolphthalein. The color of phenolphthalein does not change with acid. The color of phenolphthalein only changed in base. So, last point is mineral acids are very corrosive, so they are dangerous to touch and taste. Mineral acids are very dangerous. So, before handling the mineral acids or before handling any types of acids, we must be very careful. Otherwise, it burns our skin or it may have different negative impact in our body. And the chemical properties are, an acid reacts with metal to form hydrogen gas. Similarly, acid react with base to form salt and water, that means it is neutralization reaction. The acid react with base to form salt and water. This salt and water are the product from the acid and base, so it is also termed as neutralization reaction or acid base reaction. Similarly, acid must give hydrogen ion when dissolved in water, and acid react with metallic carbonate to produce carbon dioxide. All metallic carbonates and bicarbonates, you can say all metallic carbonates and bicarbonate. Metallic carbonate means those substances having CO3 as the negative radical and the metal as the positive radical. This combined as the metallic carbonate. must give carbon dioxide when react with acid along with the water and metal salt, along with the water and metal salt. You can see the example: acid plus metal, acid plus metal hydroxide, acid plus metal oxide, acid plus metal carbonate, acid plus metal hydrogen carbonate, that is bicarbonate, metal bicarbonate, hydrogen carbonate means metal bicarbonate, acidic oxide plus base, that is salt. Let us take some example. I will show the examples about this, like this. Acid, we are very known to the acid HCl, hydrochloric acid, plus sodium hydroxide, that is base. It is sodium hydroxide. Just look at the board please. Sodium hydroxide and hydrochloric acid. Hydrochloric acid, this is acid, this is base, and it gives sodium chloride plus water. Sodium chloride plus water. Sodium chloride is salt, it is base, it is acid. Just please in the board, acid plus base give salt and water. You can change the hydrochloric acid with another types of acid. You can take like the example H2SO4, it is sulphuric acid. Sulphuric acid plus KOH base, potassium hydroxide base give potassium sulfate plus water, it is salt and it is water. You can balance the chemical equation. In previous classes we already discussed how to balance the chemical equation. So sulfuric acid means acid plus base gives salt and water, acid plus base gives salt and water. Similarly, metal plus acid give metal salt plus hydrogen gas, that is metal displaces the hydrogen gas from the acid. Metal displaces the hydrogen gas from the acid. So metal means, you can take the example of zinc, it is metal. Take the example HCl, so give zinc chloride plus hydrogen. For easier, please to balance, check the number of zinc, it's okay. The number of chlorine here is 1, the number of chlorine here in the product side is 2. So required number to be multiplied is 2, and then count the number of chlorine, it is balanced, 2 chlorine balance, 2 chlorine balance, 2 hydrogen. So it is balanced chemical equation. Metal acid gives metal chloride plus hydrogen. Similarly, for the another one, acid plus metal carbonate gives metal salt plus carbon dioxide plus water. So acid, take example hydrochloric acid, metal carbonate, calcium carbonate. Calcium, it is metal, CO3 it is carbonate, metal carbonate, hydrochloric acid, this is acid, and here you can see metal salt, calcium chloride plus carbon dioxide plus water. Now check whether it is balanced or unbalanced. I think it is unbalanced chemical equation. So to balance, we must multiply either to the reactant or product by an appropriate number. This method is known as heat and trial method. heat and trial method. So, hydrogen HCl, CaCO3, CaCl2, CO2 and H2O. See, chlorine here is the number of chlorine is 2 here, the number of chlorine is 1 here in the reactant side. So, multiplied by the suitable number, that is 2, the number of chlorine is to balance here, the number of chlorine is balanced here. Now, for the number of calcium, 1, it is already balanced, carbon balance, oxygen C in the reactant side only 3, oxygen in the product side only 3. So, it is also balanced. Now, check the number of hydrogen. If the number of hydrogen is balanced, then the chemical equation is balanced, then H2, 2 number of hydrogen, 2 number of hydrogen. So, it is balanced chemical equation. These are the some example of the reaction between acid and different types of other compound. Now, in slide you can see the uses of acids. What are the uses of acids? As in my starting lecture, I am telling you that we are knowingly and unknowingly using the acids, base or salt, but later on their uses have been more clarified. Whatever acid we used and whatever acid we cannot use. So, mineral acids, most of the mineral acids, or we may say that all types of acids are used as laboratory reagents. For doing the different types of experiment, we use acids as the laboratory reagent, chemical reagent. Similarly, second one is sulphuric acid is used for manufacturing drugs, chemical fertilizers and detergent. Say chemical fertilizers, detergents and drugs, sulphuric acid is used. Similarly, nitric acid is used as the used in the manufacturing of chemical fertilizers, explosive, plastics, and hydrochloric acid is used for bleaching purpose in textile industries. We are very known about it. Similarly, boric acid is used for washing the eyes and the wounds. If something get inside in our eyes, boric acid is used simply to clear that eye, that substances or that particles from the eyes and the wounds also. Similarly, carbonic acid is used for making the soda water and soft drinks. Those soft drinks we used in our daily life is made by passing the carbonic acid or made by passing the carbon dioxide under the high pressure. That carbon dioxide react with water to form carbonic acid. And similarly, last one is acetic acid is used for flavoring foods. It enhances the taste of foods. Similarly, ascorbic acid is used in the treatment of the disease called scurvy. Ascorbic acid is used in the treatment of disease called scurvy. Here is some acids which are using in our daily life, which we used. Some common acids that are used in our daily life and their sources are citric acid. It is obtained from the lemon, tomato, all types of citrus fruit. Tartaric acid, that is obtained from the food like bogate etc. That is also falls under the category of citrus fruit. Similarly, oxalic acid, you can see in it is the Nepalese name, that is cherry amilo. Oxalic acid can be extracted from the cherry amilo. It is used in Ayurvedic medicine. Cherry amilo widely used in Ayurvedic medicine. Similarly, ascorbic acid is used or used for different purpose, either used to enhance the sourness of food. It is obtained from the citrus fruit like the lemon, orange etc. Similarly, lactic acid is found in milk, curd, and the formic acid, that is it is also known as methanoic acid, common name formic acid, and its IUPAC name or chemical name is methanoic acids, which is obtained from the ant bite. We feel the burning sensation when the ant stings in our ant bites due to the presence of that formic acids. These are the common acids which are used in our daily life or which we used knowingly and unknowingly, and their sources. Okay, let us see the figure, that is you see the bogate, that is ant bite, and that cherry amilo. These are the different source which the organic acids can be obtained. Okay. In our coming classes or in our next class, we will discuss more about base and salt. Till then, if you have any queries, please feel free to ask in Facebook Live or YouTube Live or in any other medium. So, till then, have a nice time. Goodbye.